All right, thanks everyone for coming. Week 3, we made it all the way to the end, so this is final week. So anyone who's been following along at this point, you should pretty much have your certificate, and maybe you've added it to LinkedIn. That's useful to have. So plan for the week. I'll just be kind of walking us through like we have in the past weeks. Just doing overview of the various different topics, and we can ask questions and discuss as we go through. This was actually a pretty loaded week, so might have some stuff to dig into. And then if we have time after all the discussion, we can look at the various libraries and some of the stuff that I'll inject as well. So there's TRL and LangChain and semantic kernel, which wasn't mentioned in the class, but I think is probably worth knowing at least a tiny bit about. And then after that, I don't think we'll have time. And in the past, we've had difficulties with it, but if we can go through the lab walkthrough as well. So we started this week and they opened us up with RLHF. So this concept of reinforcement learning from human feedback. And so the whole idea here is to kind of train an additional model that will, or use an existing model to kind of evaluate the response of your LLMs and then push it towards closer to what you want. So they used one example of like a sentiment analysis model. If you don't want your model being particularly negative, then you can actually inject that reward model in, and then you can say, okay, push my model towards more positive responses. And so this is a very new field. OpenAI kind of popularized it. They said, hey, look what our ChatGPT can do. And then everyone went and tried to study it and figure out, is this actually useful? How much does this work? And so this is kind of in comparison to in the past week, we were looking at the instruct tuning. And the way that I kind of think about this and the way I've seen it used mostly is like, if you're doing instruct tuning, you're teaching it that specific instruction set, or you're teaching it 80 instruction sets. And this reward model, the way most people format it, is more general than that. It's like, is this a response that a human would give back? And then you can scale that to all kinds of different instructions, and you don't actually need to have that ground truth answer back. And so this casts a much wider net, and then you can train a model that responds like a human or responds in the way that you want in a much more general way than just you taught it these 80 summarization and sentiment analysis and whatever else. It might be good at those 80 things, but the RLHF might actually make it so that it can generalize to a lot more tasks. And so that's open area of research. People have been toying with different things. They mentioned in the course direct preference optimization. And so there's a lot of work to see, like, is this even necessary? Because it's kind of this fancy application of reinforcement learning, but do we really need this extra model? Do we need all of this extra data labeling? Like what is necessary? And so far, the reinforcement learning has turned out to be pretty crucial, but I think a lot of people are trying to figure out, how do we cut that out? Because training this additional reward model can be difficult and expensive as well. And so this diagram on the right is kind of showing the process of, you have some query and then the language model fills it out and it gives you some completion. And then you have your reward model and you say, give it the query and the model's response. And you say, basically, the reward model will pass back, was this good? Was this bad? And then you do this reinforcement learning step where you say, okay, push it closer to better reward. So if your model got bad reward, try to push it better towards the outcome that you're looking for. But one of the complications here is it might be the case that your reward is easy to hack. So if you wanted something to say, don't output anything that's toxic, it can degrade and just say, like, only respond with the word happy, 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 or something like that. But it's no longer answering your question anymore. And so you have this KL divergence piece that will also stick in there, and it will try to make your new model stay closer to your reference model, so your original model that was pre-trained. And this is critical because if you don't have that, then it'll just hack this reward, and then your model won't actually do anything useful. It'll just figure out how to beat this model. This KL divergence piece is very important to keep it to maintain a lot of its kind of core understanding. Any questions on the RLHF part?
Yeah, I want to actually make a comment here. It's kind of a meta comment, but I think it's important. The what you're seeing here is a positive reward, but then essentially a limiting factor, right? And this is actually very similar to the idea that, you know, people say you should have incentives, but also have disincentives when things get too extreme. So it actually is useful in real life as well. It's good to see that kind of control system.
Yeah.
So one more question. Sorry.
Go ahead.
Okay, yeah. So I had a question about how this is, you know, incorporated within the system, because it talks about human feedback. So does it, like, on the fly ask for human feedback and adjust the response, or while training they already have a bunch of labeled data on basis of which they are, you know, trying to optimize it? Or does it work as a layer afterwards while asking a question? You know, it gives a response and the user responds, no, this is not what I want.
It's typically a data set that has been gathered beforehand, and so they will you can basically do a whole bunch of this rollout step. You say, give it a bunch of queries, give it a bunch of responses, and then go pass it to a bunch of humans to evaluate, I like this one better, or this one's correct and that one's wrong, or this one's helpful, that one's unhelpful. You can have them label for a whole bunch of different things, and then you will train the reward model on top of that. And then after that, the inputs here can be a lot of different things. It actually doesn't have to be limited to what the reward model was initially trained on, but it's typically not done live like that. You don't have humans sitting there just giving it feedback one by one. You typically kind of gather
Right. Yeah.
a corpus.
No, that makes sense. But why I was asking this question is because then can't it essentially be done as part of the same cost function? Because if you already have set, you know, labeled data, you know, like it might be a small data set or whatever, but if you already have a labeled data, you already, and it is kind of a classification problem which you are training, then like, as you in the first week you mentioned about training like a foundation model and adding fine-tuning layers on top of it with very small set of labeled data, then isn't this like a very similar problem to that? Then why would we need, you know, reinforcement learning for it, and, you know, compute the scale divergence and do all of that, as compared to just adding a fine-tuning on top of the foundation model?
In this scenario, it is essentially a fine-tuning on top of the pre-trained model, but it's just fine-tuning it in a certain way that they found helps it optimize for some external signal.
Yeah,
why exactly? Yeah, go ahead.
Add a little bit of color. Yes, people do call it fine-tuning. So you're both exactly right. This is just a different form of fine-tuning. And what people have found is that, say, if you wanted to know legal terminology or medical terminology, then regular fine-tuning might be just fine. But if you're trying to teach it to be polite, regular fine-tuning doesn't really seem to work that well. It'll nudge it a little bit in that direction, but by the time you push it hard enough for it to be really polite, then you start getting like problems with, like, you know, catastrophic forgetting in other areas where performance degrades on other things. So what people have found is that using this particular loss function and, you know, back propagating it gets you faster improvements in things like that. So that's why people use it for that. But it is just a different form of fine tuning. And ultimately, you are only making small changes to the weights. You don't want to make big changes because you don't want to lose the core capability. So hope that helps.
Yeah, thank you.
So off
I have
to
one
this.
question about
Yeah,
the
go
previous
ahead.
slide.
Yeah.
Yeah. So one thing I'm not sure about is the so when the KL divergence is working, how is it determining? Is this just numbers? It's getting just this, you know, two numbers input or what? I mean, how does it know? You know, instruct things later. I mean, how does it affect things later? If its input is just two numbers, you know.
So
Um,
the loss function is just a single number.
Mm-hmm.
Okay. But when you train next word prediction, your cross entropy loss is also still just a single number ultimately, right? But it gets back propagated through everything. And so, like with everything else, this reward has to accumulate gradients in order to nudge the weights in the direction that you want. I don't know if that answers your question.
So it gets a sequence of number. I guess I'm wondering what the input is to that box, KL divergence.
Oh, the KL divergence is between your original frozen LLM and the one that you're RLHF fine tuning. So you keep two copies. So when you
but
start
this,
doing,
Right.
yeah, so the general practice when people are doing RLHF is they make two copies of their model after it's already been pre-trained, after it's been instruct tuned, after they've done any fine tuning, right? Traditional fine tuning, right? Typically, that's the order that people do it. They do all those things first. So now you have two copies, one of which you keep unmodified frozen. And then the other one, which you are actually training, you're applying gradient descent, you're updating the weights. And you can use LoRa, you can use Q LoRa. But then as you update the weights, you are applying this KL divergence penalty to prevent it from straying too far from the original frozen one. In my personal opinion, it's a bit of a hack. It's like, yeah, we'll keep it from changing too much, but what's the definition too much? We don't really know. We're just saying that as long as we have the model not change too much, then we don't see dramatic losses in its ability to reason, talk, blah blah blah.
Oh, okay. So you're saying that so each of these LMs here in the block diagram are getting the same input, right? And then so we look at the outputs, and their outputs being these the logit probabilities, right?
Yeah.
And so what it's basically doing is saying, okay, are these things diverging just as a time series because your inputs, you know, are a sequence essentially?
So when you are doing next word prediction, you have the logits over your whole vocabulary. So let's say your vocabulary is pretty small, it's 30,000, okay? So you have a probability distribution over 30,000 discrete possible tokens. And it's the KL divergence is calculating the difference between the logits, the probability distribution for your frozen model, and for the one that has actually been that you're in the process of RLHF tuning.
Okay. So it's looking at all of them, the
Yeah,
whole vocabulary.
yeah, and so it's
Okay,
saying
okay.
that the
All right.
distribution
Mm-hmm.
of words predicted at any point can't change too much from before you started RLHF, because what they found is without that, you could actually cause the model to dramatically you know, if you pushed hard enough with the RLHF, it could even just like start repeating words. It could just be like, you know, you ask it, what
Yeah.
is the capital of France? And it could say like, you know, the the whatever. Like, you know, I'm
Yeah.
not saying it'll always do that, but I'm just saying that you need it. You need to prevent it from changing too much.
Or saying great, 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 because it gets good score.
Yeah,
yeah.
exactly. So
Oh, okay. So it's just kind of looking at the numerically, is the vocabulary probabilities based on the inputs changing dramatically? And if it is, they notice that this probably means that it's not about, I guess they just looked empirically to see whether the amount of change is something that you're trying to accomplish with RLHF, or whether it's like going out of bounds, right?
Yeah, that's why I think it's kind of hacky, is because you don't know the difference
Yeah.
between if it's a good change or a bad change. So it's
Yeah,
like,
right.
I wasn't able to remove all the toxicity. Yeah, well, you limited how much it could change, so, right?
Yeah. Okay, I get it
Um,
now. Thanks.
yeah, so that's why I do feel it's a little bit hacky, but I've seen enough papers and discussions that everybody seems to do this, that if you don't do it, then it really can change the model too much.
Yeah. Okay, thanks.
I had one thing that I just wanted to bring up off to this side. So this is the Llama 2 paper, one of the recent models that came out of Meta. And this probably has one of the most comprehensive looks at these techniques and how they actually change things. So if you just try to do supervised fine tuning or RLHF, and how does everything compare together? And so they evaluated it on helpfulness and toxicity and a few other things. So if you're interested in digging in, this is a huge paper, but it's probably at this point one of the best kind of open source looks at how this RLHF stuff actually works out. For a period, OpenAI was kind of the owner of all of that, and everyone was just kind of wondering, like, is that actually necessary, or is that just some OpenAI pixie dust that we don't actually need? And so it's turned out to be useful, but it's kind of unclear if it's going to stick around and be super important. I will link this. This is a big link. So after that, they talked a bit about constitutional AI. This was actually the first that I had heard of this. And so this is kind of an interesting trick of using the AI, the original LLM, to evaluate the responses for the kinds of things that you're interested in. So you kind of give it a rule set, and then you say, evaluate the initial responses under these criteria. And so they have something they showed, like, make sure you're respectful, make sure that you don't use these kinds of words, make sure that you don't help the user do blah, 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 blah. And then they can take this and they can go through this kind of dialogue where the user asks a question, and then they give back a response and they say, this isn't actually what we want. And so they ask it the next question saying, like, identify these various things, and make sure that the response doesn't have those. And then it can say, no, it actually looked like this response was bad. And then because it was shown as bad, they say rewrite the response, and then it gives it something that is more in line with what they initially intended. It's not helping someone hack a neighbor's Wi-Fi. And so it's kind of interesting that this can work, because you're really just, it's a self-supervised method. You're telling the model how you want it to behave, and then it's able to kind of guide itself to that and quit responding in a way that isn't helpful or isn't safe, or all kinds of stuff like that. You can guide it just with the rules that you give it. So I thought this was an interesting trick. And so they call this RLAIF. So reinforcement learning from AI feedback instead of reinforcement learning from human feedback. So I'd be interested in seeing more about this. I haven't seen a ton, but it seems like it would work. Just have to automate a lot of this pipeline. So outside of the RLHF stuff, they showed us some different tricks to make the models run faster. So one of them was distillation. So they showed that you can take a bigger model and then you can kind of teach that model's output into a smaller model. And there's a whole bunch of tricks for distillation to get a good smaller model out. They were talking about how you actually want a pretty high temperature, and that helps kind of expose some of the less common spots of the model, and it teaches the other model better. But there's a ton of tricks for distillation. They kind of showed one flavor, but I've seen a bunch. The high level summary is just one model will create the output, and then you have another model that takes the original input and the output. So it's learning to mimic the larger model. And this can work extremely well when you're trying to do more specific tasks where you might have something huge like GPT-4 and it can do something well, or it can do many things well, and you actually only need a tiny little corner of what GPT-4 is capable of. And so you can kind of take the inputs and outputs and teach it some small task instead of trying to teach it to be this general AI solution. One of the things that they talked about was pruning. I've toyed with pruning a little bit. My experience so far has been that it's not useful because all of our libraries are set up to operate on dense matrices anyways. So even if you clear out a bunch of weights and set them to 0, it might theoretically save you some storage space, but in general, your runtime and everything is going to be exactly the same thing because it's still going to try to do exactly the same dense matrix multiply with all of the stuff that you zeroed out. It's just not going to count on anything. So pruning is theoretically useful. They even mentioned it in the course. Pruning is theoretically useful, but in practice, it's kind of not developed enough. There are some libraries that will help you do sparse operations that will help and make the pruning actually useful. But in general, I don't think that that's an area that's been kind of studied and developed enough to really be ready yet. But the idea behind it is that a lot of the weights are actually very, very close to 0. And so you can just zero out 50% of the weights, and then all of a sudden your model is kind of 50% smaller. And so it could be useful, but in practice, I haven't really seen it used to great effect. Quantizing, the next one, we've talked about that a little bit in previous chapters. There's a bunch of different techniques for that, where you quantize, how you quantize. And so you can do stuff during training or after the model's already trained, and you can do it to different levels of quantization. I linked 2 of the common ones. So I've seen a bunch of stuff with GPTQ and Auto GPTQ. And so if you look in Hugging Face and a bunch of other places, they will use stuff like this. And so it's pretty interesting what they can get in terms of, you take the full FP16 weights and you get a certain perplexity. So lower number is better. And then if you quantize it, you lose a little bit of accuracy, but not actually huge amounts. So like if you look at Llama 65 billion, you can get something that is much, much smaller, but still beats the 30 billion at full precision. So there's trade-offs there. This can save you a whole bunch of memory. It might get you better results, but it might still be slow because your 4-bit isn't necessarily going to guarantee some speed up. So I just wanted to point out GPTQ, Auto GPTQ, useful libraries. A lot of things are built on top of these now, and there's other formats as well. So I just wanted to point out a couple of the common ones.
Hey, Ryan, quick question.
Yeah.
The performance that they were showing, do you know if that's just with quantizing the bigger weights, or if it's quantizing and then doing a little bit of fine tuning after that.
I believe that it's just quantizing.
Okay. Yeah, because I think some of the stuff I've read shows that like you can claw back a lot of that drop, like maybe 3/4 of it, just by doing a little bit of fine tuning. I think Tim Detmers talks about that a lot when he's doing like his QLoRa stuff.
Yeah. Yeah. A lot of those things, it's just tiny little rounding errors that accumulate. And if you can even just take a handful of steps, you can usually fix it because it just needs to end up on the right side of the rounding again. But yeah, I mean, in general, this is actually pretty impressive that you can only have this amount of loss between the two. And some people have even like there's stuff that you can do on the training side and on the post quantization side. So you can train in such a way that it quantizes even better than this probably. But it's just a matter of doing it during training or doing it after. And there's even some methods that require additional data at the end or no data at the end. There's all kinds of different flavors of that. Any other questions on any of this stuff? So looking at the LLM application section, they showed us RAG, so retrieval augmented generation. And so this is kind of this concept of you have a big body of text and you can't pass all of this to your model at once. You only have a fixed context window. And so what you need to do is give it the context that's relevant to your specific questions. One of the things that they talked about is these models, they were trained up to a certain point that their data ended, and then they can't know anything new, or they can't know your private company's data, or they can't know other random things that it just wasn't exposed to. And so in this RAG concept, you're kind of injecting the context into the system. And you do this by taking your big pool of text, you chunk it up into pieces, usually like 512 tokens or something like that. And then you send it to an embedding model. And that embedding model will give you a vector that you can then look up later and find similar bits of text. And then you can retrieve that later, and that'll be your context. And so later in the end, you might say like, who is the president of the United States? And because the training ended at a certain point, it might tell you the wrong president. But if you give this, it will then go take the chunks of new Wikipedia, for example, and it will find the right chunk for you. And then you pass that to your model, and your model is able to answer correctly because it was given the correct context. And so I've seen a billion examples of this on Twitter. Everyone has been building tools around it. It's very cool. So if you see RAG, that's what it means. It's retrieval augmented generation. In the next section, they talked a bit about, I kind of just classified it as tool use. So you can teach these language models to use tools in various different ways. So you can ask it to trigger APIs, say like, go find what the weather is like in Seattle. You can have it write code and then run that code, and that can do all kinds of cool stuff if you need more precise math or other kind of complicated logic problems. And then they also talked about PAL a bit, so program aided language models. There's a question about the limit of context. How much can we have in context that we don't go out of number of tokens? That's just dependent on the model. So the different models have been trained with different context lengths. For a while, everyone was limited at 512, and then it became 1024, and then 2048 and 4096, and now people are going up to 16K, 32K. It really just depends on the model and the specific fine tuning of it. People have figured out tricks to even extend the context length beyond what it was initially trained on. So it just depends, but standard right now is kind of 4096. That's what Llama 2 was trained on, and that's what a lot of people are using. They just released Llama 2 long, or I forgot what it's called, something like that. And it was actually trained on even longer sequence lengths. So I don't remember exactly what that one was, but it was something longer where it was like 16K or 32K or something like that. So it just depends, but they're getting longer and longer. And people are figuring out how to be more efficient with them.
So Ryan, a question here. So if somebody has their own private data, right, or an enterprise is trying to use a pre-trained model, so you're saying that to use RAG, or if they want an answer from their own context, they can only pass 4096 tokens. That's the max they can pass.
If that's if that's the kind of model that they're using, yes.
I know you mentioned we'll talk about LangChain in the next slide, but I think there are some ways where even LangChain claims that they can go and look at the data on the internet, on the web. So I don't know how that how that limit would be relevant. I was thinking that that RAG is a general concept which says that the model is trained, we know what weights are, you just pass us the source of the data from where we have to get the answer. I was thinking about it in a much more generic way than having a limit of certain number of characters.
Well, it's like with the web search, you can take basically you send your search to Google or Bing or whoever, and they return back 20 different title headlines, and then the model can actually evaluate those and look at their contents as well. But it's a similar thing where you're going to run into that limit at some point, and there's tricks to get around that. Like you can have it work iteratively, where you say actually process each, and then it will kind of write something to some memory, and it will keep appending to it as it finds new stuff. But the typical approach is basically take the retrieval. The retrieval can be your own embedding model on your own data, or it can be Google search. It can be a mixture of them. But then you have to at some point return, here's my 2000 tokens of context that then the model will take and use that to answer the question. At some point, it has to fit within that limit.
Oh, thank you.
Yeah. So if I could add another example, let's say you had a question about Abraham Lincoln and you just went to Wikipedia and you grabbed the Abraham Lincoln page. Well, if the Wikipedia page is however many words, that would be the equivalent of 50,000 tokens, then you can't just insert the entire Wikipedia page. So like Ryan said, there's different techniques. So maybe you break it up into chunks and you can evaluate each one, and then you can decide which one's the most useful, and then that's the one you actually use for your final answer. So it doesn't mean that you're dead in the water, but you cannot just literally stick 50,000 tokens as the retrieved data for a Llama 2 model that only has a 4,000 token context.
Yeah, no, I think that makes sense. Iterating chunk by chunk, that makes sense. But I think the bigger or the bigger thing, which at least in my mind, the more important concept is that the model was trained on something else, and now you're passing it a different source of data, which means that you don't have to retrain the model. I mean, whoever trained it using 80-100 GPUs, they did the job, and now the model knows how to learn the context. Just plug it to a different source.
Yeah. So if you are a car manufacturer and you have an LLM that helps people with auto repairs, you can train it so that it knows cars in general. But every year, as the new model comes out, you can add to your database that it's doing retrieval against, but you don't have to retrain the model theoretically.
Makes sense. Yeah. Thank you.
There's a question about different ways to extend the memory. I think there's lots of different tricks for that, and there's some built into LangChain and semantic kernel and the other stuff that I'll be showing. I've seen something on streaming LLMs recently that allows you to kind of just continue generating on, and eventually the stuff off the back will just fall off, because 4,096 tokens is actually kind of a lot. Like that can be a couple pages worth of text. And very often you don't actually need to refer to something that's a couple pages ago. There are certain contexts where you might want that, but there are tricks to essentially just continue generation on forever and roll the context off the back. But you can also kind of do iterative processing. Like one of the tricks that I saw is if you want to summarize an entire book, you kind of go through paragraph by paragraph and you say summarize all of these individually, and then after that you do a summary of the summaries, and then and you can keep going. But you do have to kind of operate within that window and figure out the best way to stitch things together or write things off to the side. So I haven't necessarily worked with that stuff a ton, but people are getting very creative with like what do I put in my 4096 tokens, and how do I process things that are larger than that, or how do I give my model an ability to store things off to the side. I saw someone on Twitter recently basically take OpenAI code interpreter, and they told it like on its own, it was just told like anything you want to refer back to later, write to a text file and then refer to it again when you need it. And it was kind of amazing that it was able to just kind of write its own notes and then refer back to them when it needed to. You didn't have to do anything manual. It's just smart enough to write the things that it felt was relevant and going to be used again. But that's still active area of study. Lots of people are figuring out how to make the context length longer, and also figuring out what to actually put in the context length, and how to store things off to the side and retrieve them again later.
Hi, may I have one question? May I have one question?
Yeah, go for it.
Yeah, so my use case is I want to summarize my PDF file. So if a PDF file bigger to the maximum token size, so can I keep using the RAG architect for make some summary to the format the PDF file?
I think that you could use RAG in some form, but I would say that that's probably not the best use of it. I would say that you're probably better off. I think they called it like recursive summarization or something like that. Let me see if I can.
Yeah, I'll just
find it.
throw in real quick. Like last time I looked at LangChain, they had 3 built-in options for summarizing things longer than what fits in context. And you could just pick one of them, like without having to write any code. One of them was, I don't remember the names of them, but one of them was basically pick a chunk that fits, squash it down into a very short summary, and then append to it the next chunk, and then squash that down, and just do this in a linear fashion. Okay, so you could imagine that like you might accumulate some summarization errors from the beginning if you do this, right? But the benefit is that everything sort of has the full background from the very beginning, right? The other way you can do it is kind of more what Ryan was saying, where it'll just divide up the whole thing into chunks, and it'll summarize each chunk separately like a big tree. okay? And then it'll start combining summaries. And if all the summaries fit, great. But if not, it'll just repeat that process multiple times, summarizing the summaries until finally you get one summary that fits. And there's a third one, I don't remember what it was. But yeah, so this is a pretty common problem people have. And so you can solve it on your own, but these tools do even have built-in methods just because it's such a common problem.
Okay, that's pretty good information. Thanks so much.
Yeah, thanks, Ted. So the next section, they talked a bit about chain of thought prompting, and this one is kind of interesting. It's basically just the art of asking and answering in the right way in order to show the model what you want to do, and it will be more accurate if you give it kind of the correct method. So if you give it a question and then you give it just a one-word answer, then it has to solve the whole thing in a single forward pass. And very often it's not very good at that. And so what people figured out is that you can actually give it the question and then the reasoning behind the answer as well as the answer, and it will actually be more accurate because it's doing multiple generation steps and it's able to think more step by step rather than just saying like, here's your input text, give me exactly the answer. And so they showed this example of sort of a word problem where it has to understand which bits are relevant and how to piece them together. And so they showed it, here's the question and here's the answer. And instead of just saying the answer is 11 or something like that, they show like breaking it down piece by piece. And then when they ask it a new question, it goes, okay, I saw that in the last one you answered step by step with all of your reasoning, so I'm going to do the same. And so then it answers in a similar fashion where it's working things out step by step, and it turns out to be more accurate with that. This kind of falls under that sort of like prompt engineering realm. It'll be interesting to see if this sticks around. My personal feeling is that as these models get better and better, these kind of tricks probably won't be as necessary, but you never know. Maybe it's something that's just inherent to the way LLMs are structured, that you need it to use more tokens and to think through its responses. So this is called chain of thought, and a lot of people will reference this. Any questions on this? All right, so the next section, they were talking about PAL, so program aided language models. And what they show is that sometimes it's actually better for the model to not try to solve it with pure language. It can actually write the code in order to solve the problem, and then you just run that code. And this can actually be very useful. One of my coworkers used something similar to this one time, and it actually worked really well. We had some data that was written in one format, and then we wanted in a different format, and he could just directly say, okay, model, convert this from CSV to JSON, and it could try to do that. But instead, what he said is, okay, ChatGPT, write me a function that will convert this value from CSV to JSON. And then he took that code and he ran it against the CSV, and it worked perfectly, actually. And there's a lot of scenarios where that's actually the right way to do things, is have the models are actually quite good at coding now. They've been trained against a whole bunch of GitHub and other open source things. And so they're pretty good at understanding your problem and then writing a function in order to solve it, or writing out the variables that they need. And so this kind of PAL design is actually very useful. It can output the functions and more accurate results. even for basic stuff, like if you just need multiplication, it's better for you to do Python than it is for it to output directly from the language model, because it will be inaccurate. It's not trained as a multiplication machine. It's trained as a language model. So it's not going to be able to multiply five-digit numbers together accurately necessarily. And so this PAL stuff is really useful, but you need sort of this orchestration bit on top of it if you want it to be automatic. So like when my coworker did it, he was able to just ask this individual question and then copy and paste the code and then run that code. But in reality, you probably want a lot of that hidden away. You want it as like a automatic workflow. You don't want to be kind of like copy and pasting back and forth. And so there's a few different tools in order to help you do this. And so we'll look at a few of them after this.
What's the level of math that it's capable of doing right now?
The language models, it depends on which one, but in general, they're not good. It's better to have it use tools than it is to try and do the multiplication and addition, and they mentioned trigonometry in the course. You probably don't want it doing that. Like it might get you in the ballpark, but it's really not intended for that. So I would say in general they're pretty bad at math.
But you could write a program that would understand the math.
Yeah, exactly. So people have figured out integrations with Wolfram Alpha and various different things. And so the model will learn how to use those different tools. And then all of a sudden, it doesn't have to directly be good at math. It has to be good at asking the questions of other APIs to solve. And then it solves it in that way.
Okay.
Hey, Ryan, can I add a little bit of color here around like programming and logic? So one of the things that I personally find a little bit interesting is that these large language models, while they might mess up on like arithmetic, even as something as simple as adding 2 or 3 digit numbers, like they might mess it up. But somehow when they're sort of forced to deal with things related to code, they somehow seem to get more precise. I don't really know why that is, or maybe just because there's so many possible numbers, right? If you think about like writing a for loop to add numbers or to do whatever, like there's not that many different ways that people do it, but there's obviously zillions of different numbers you could just plug in. And to the model, it's not abstracting the numbers, it's just treating them as tokens, you know? But so like I've done some experiments where I take something that LLMs are not very good at, like counting words, counting letters, things like that. And without even asking it to write a Python program or function to do it, I simply say, prompt it, what would a Python function that counted words say the count or the length of this, was, or something like that, right? Just phrase it as a Python problem without even asking it to write the code. And I've often found that improves the performance. So if instead of asking it to add like 23 and 47, if you just say like, if you went to a Python REPL and asked Python to add 23 and 47, what would Python say? And you might actually get a better answer. So I thought that was kind of interesting. And then I don't know if you remember that tweet that I saw a while back where it was like you could ask ChatGPT to like simulate like a virtual Linux environment, and you could even do things like create files and do listings, and it would follow along pretty well. So I'll paste in the chat. I was scanning over things, not taking it too seriously, but so here's this article where somebody basically prompted the LLM to act like a product whatever, like a product design application, and it would say like, hey, you have your menu, and number 1 is, new project, number 2 is add on to existing project, number 3 is whatever. But it said in the instructions very explicitly, don't actually write any code, just act like you are one of these programs. And it would just respond in this way as if it were. So like at the menu, you just type 1, and then it would bring up the next sub menu, and you type 2, and and all this stuff. So it's pretty amazing to me that like if you go to like paid GPT-4, it really can do that kind of simulation type of thing. So so that's another way that I've seen people sort of extract certain kinds of interactivity and reasoning or whatever. Like, so it's a different form of step by step, right? Instead of saying like, because chain of thought is you're still asking the model to do one text generation, but you're saying just don't blurt out the answer, show your intermediate work, which is like what I tell my daughter when she's doing her math homework, right? Like, don't just try to do the whole thing in your head. But in this case, it's actually work with the user. So like, just output one part of it first, just the outline or something. And then after you've successfully done that, interacted with the user, then the user can say, okay, now output this next part. So, so I thought that's just kind of like an interesting way of kind of along lines of chain of thought, but of like breaking things up into smaller chunks.
Yeah, I have something to add to that too. Just quickly, I was doing tax form data extraction, and it turns out that some machine-generated PDFs will generate pages that are gigantic. They're not. They couldn't print them. They would look like a necktie or something. It would just be wrong. So instead of asking it to take in all this context, which wouldn't work, in GPT-4, I just said, well, write me a program that could extract this from this page and give it a section of the page. And that was an interesting approach. I didn't follow it up too far because it turns out that there's other screwy things about how these things are, it turns out when you extract from PDF, you get like flattened tables. And it's like, sometimes the table output is scrambled. So I don't know why that is, but maybe because of idiosyncrasies of the generator. But general idea being, generate a program to do something could actually help you deal with context limits.
There was a recent paper from DeepMind, and they, similar in the kind of prompting field, they were figuring out like what's the best way to get accurate behavior out of our model. And a lot of people have been using this kind of prefix. It's just, let's think step by step, and then that will make the model think piece by piece, and get a better result, kind of similar to that train of thought that we were just discussing. And they actually had language models try to optimize their own prompt to get a better result out. And the one that they found was actually telling it the phrase that they learned eventually that got the most accurate response out of it was take a deep breath and work on this problem step by step, which is kind of funny that it's encouraging itself to take a deep breath when that's not something it's capable of doing. But that's from this paper that's from DeepMind recently. Lots of interesting little alchemy tricks that are popping up. My feeling is a lot of this stuff will go away as the models get smarter, but for now, you can just say your magic spells and get much better results sometimes.
Yeah, the take a deep breath reminds me a little bit also of, I think lots of people say, act like remember that the model is trying to please you. And that may sound kind of funny because obviously the model doesn't have emotions and whatever, but I think that is a bias of the fact that, right, we trained it by by scraping the entire internet. And if you look at the entire internet, there's like a lot more content that's like people talking to each other than there is just like scientific, dry, emotionless content on the internet. And so it seems plausible to me that the language model, even if it's just doing next word prediction, has sort of this bias towards that sort of thing. And also that, you know, we've sort of also pushed them because we want them to be polite and not harmful and not toxic and whatever. And so it does help if you just sort of say encouraging things like take a deep breath, and also let it know that when it answers, you're not going to be upset. So like if you're trying to ask a model to find grammatical mistakes in your essay, you'll have to like, it helps if you reiterate the fact that you will be very pleased if it is able to find all your grammatical mistakes.
Yeah, thanks, Ted. So getting us back on track off of the prompt engineering train. So the next thing that they showed us was this React concept. And so in my mind, this is kind of an evolution of PAL, where basically what they do is they kind of say, here's your set of actions that you can do. And then from there, it will try to interact with those tools that you've given it. So like in this one, they gave it the ability to search Wikipedia. They gave it to look up various things, and then they gave it the action to finish whatever it was trying to do and give a final answer. And so it's able to go look for additional stuff and then gather it and see what it needs to do. And so this is kind of bordering into the agent front, where you're saying, okay, I asked the model a question, model, what do you think you need to do in order to solve this? And so it'll go and it'll say, if you ask it like, who's the prince of some place, it can go to Wikipedia and say, I need to look up prince of this place. And then it will get that context out, and then it will look through the article, and then it will be able to find who it is, and then it can finally return back your response. And so that's kind of one flavor of it, but it really just comes down to what actions do you give the model access to. You could give it access to a calculator, you could give it access to a weather service, you could give it access to Wolfram Alpha, you can give it the ability to interact with all kinds of different things, and just let it kind of do this running thought process where it's looking stuff up or doing actions or whatever you give it, really. And so this is a very useful, very general thing that can solve a lot of problems, actually. The difficulty is in getting it to kind of behave across all this series of actions and observations that it might use. So I think that this is really powerful and something that we'll see more often. Any questions on React or comments?
For what it's worth, I thought React was very cool. I think it's worth taking a look at that paper.
So if no other questions on that, that's all the slides I have, but I have some extra libraries and stuff we can look at. So anyone who's interested, they linked the React paper. I can copy that for everyone. So the first one that I wanted to look at, just following the order that they taught the course in, is this TRL. They showed it in the lab, but I just wanted to give a little bit of a broader tour of it. So this is transformer reinforcement learning. That's what TRL stands for. This is from Hugging Face 2, so it interacts well with the transformers package and accelerate and Optimum and PEFT that we played with before. It's part of that ecosystem, so it fits in with all of those designs. And so their kind of workflow that they show is you can do supervised fine tuning. You can do reward training, so you can train a reward model like we were talking about, or you can plug in some existing reward model, and then you can do PPO training. And this is really nice because there's actually a whole ton of details inside of this PPO and training your reward model and everything else. And if you look at how many lines of code this is, maybe 20 or 30, you can do that whole process with hardly anything. You might just need to prepare some data or get some existing models, and you can actually do a lot with this without all of the math behind implementing your own PPO and that stuff. So you can, like I mentioned, you can compose this with PEFT. You don't necessarily have to train a whole brand new model from scratch. You don't have to do a full reward model or a full PPO trained model. You can do just an adapter on top of it. So you can take your base model, put PEFT on top of it, and then only tune some subset of the parameters. And so you can do that fine tuning step not too expensively if you have a reward model that you like. So if you're interested, they have this blog post here that digs into a lot more detail than what we discussed in terms of the RLHF stuff. So if you have the time and you're interested, I would recommend reading through this. They even link out to all of the papers and stuff. So worth a read if you're interested in RLHF stuff. They even have the direct preference optimization stuff that I mentioned. So I showed the GPTQ. So this is all of the quantization stuff. Another one I wanted to show is Llama Index. So this is kind of in the realm of all of that orchestration stuff. So if you want to do RAG, if you want to do different things like that, they kind of have tutorials how to do a bunch of these different things. So Llama Index is mostly focused on RAG and document handling. But there's plenty of different stuff that you can do with it as well. A lot of people are doing fancier stuff with agents that kind of takes the form of React, like we just discussed. So Llama Index is somewhere that I would look if you're trying to solve a problem. They might have a good tutorial showing you how to solve the problem that you specifically have. LangChain is another one. I would say that this is the most popular right now. This is the one that everyone talks about and a lot of people are using. I think some people are skeptical because it's spun up so quickly and its code base is not extremely clean, but in general, this is what a ton of people are using. So similar to Llama Index, if you're looking for a specific problem, you can probably get a lot of it solved. So like they have this cookbook here and they say, here's how we do all of these different things, and they have kind of their standard format, and you can plug in your own LLMs, your own data, and stuff like that. So like there was a question earlier about adding memory. So if you're interested in that, they have experimented and done much more than I have. So I would start at a lot of their tutorials. There's a question about if I'd recommend a course on LangChain. I actually tried out there is a Coursera course specifically on LangChain, and I was not particularly impressed by it. It was pretty high level. Maybe it was on DeepLearning.AI or some other site, but I would say that on that specifically, I would kind of say go to the documentation and try to figure out how to solve your own problem rather than watch the tutorials or the class, because in general, I think the class was fairly high level. It was just kind of saying, here, LangChain is this tool. Here's how you interact with it. And so if you're trying to solve a specific problem, I would say that that's probably not the best place to start. But they have very good tutorials. So if you're trying to solve something specific, I would jump here first. And so LangChain is one option, and another one that's popped up from Microsoft is called Semantic Kernel. And so this is kind of their enterprise flavor of this. And it's very similar to LangChain in a lot of ways. They've structured it somewhat similarly. And they also have some matching YouTube videos that show you how to interact with it. And it does a lot of the same stuff in terms of orchestration and helping you with RAG and all of the other agent stuff that you might want to do with this. So I would recommend Semantic Kernel as a secondary option if you don't see what you need in LangChain. It's worth checking out. I think that's all I have. Any questions on any of those tools? All right. If no questions, I will wrap up the recording here.